Now let's look at the problem 50. We need to find the cotangent of the theta over 2 if theta is equal to 2 pi over 3. So cotangent of theta over 2, this is equal to cotangent of 2 pi over 3 divided by 2. So that is the pi over 3, right? So this is equal to cosine of pi over 3 divided by sine of pi over 3. And we know cosine of the pi over 3 is equal to 1/2, right? Cosine of the 60 degrees is equal to 1/2. And sine of pi over 3 is equal to root of 3 over 2. And then you get 1 over root of 3. Right, and then finally you get the root of 3 over 3. So after we have seen some examples of evaluating those 4 new trigonometric functions, now let's begin to look at the graph of the tangent function. Okay, so let's see how we plot the graph of y equal to tangent of x. So by the identities from the definitions, tangent of x is equal to sine x over the cosine x. And let's recall the definition of asymptote we learned in the Math 135. And let's look at this example, y equal to 1 over x. We know this is its graph is the hyperbola, right? Its graph is like this. Here. And this y-axis is an vertical asymptote of this function. So actually, at the points where the denominator is equal to 0, we have the vertical asymptote. So this guy, x equal to 0, this is a vertical asymptote, right? So now, in the case of the tangent x, when cosine x is equal to 0, the graph of the tangent x also has the vertical asymptotes. So actually, cosine x equal to 0, this holds if and only if x is equal to half pi plus k pi. Okay, for all those integers k. Okay, that means at all these points we have the vertical asymptotes for the graph of the y equal to tangent x. To graph the y equal to tangent x, we may compute some order pairs. Okay, let's get some order pairs. So we net x. We know at half pi, tangent x is not well defined, right? Because the cosine half pi is equal to 0. And this is why we have the vertical asymptotic at here, right? So, and half pi approximately equal to 1.57. Okay, so we may choose some value which is close to this 1.57. Let's get the negative 1.56, and you may use the calculator to compute this tangent value. And at this point, the tangent x is equal to negative 92.6, okay, approximately. And then let's take the x to be negative 1.5. Then the tangent x is equal to negative 14.1. And then let x be negative half over 3. Now, what is the tangent x? Tangent of the negative pi over 3 equal to what? First, let's determine the sign is negative, right? Then what is the value? Root of 3. Okay. Tangent of the pi over 3 is equal to root of 3. And tangent of the negative pi over 3 is equal to negative root of 3. Okay. And this is approximately equal to negative 1.73. And then we may compute the negative pi over 6. So this is equal to negative root of 3 over 3, and approximately equal to negative 0.58. And then x is equal to 0. Tangent x is also equal to 0. So similarly, you may also find some tangent for those positive x values. So you have the pi over 6, and this guy is equal to 1.73, and then pi over 3, and this is equal to, okay, pi over 6. This guy should be equal to 0.58. Let me change this. So 0.58, and pi over 3 is equal to 1.73, and then 1.5. Tangent is equal to 14.1, and then a special one, pi over 4. Tangent is equal to 1. Okay. So now, when you take more values which are close to this 1.57 or close to the negative 1.57, you can see tangent x approaches positive infinity as x approaches pi over 2 from the left. And we will see this from the graph later. And also, tangent x approaches negative infinity as x approaches pi over 2 from the right. And we can also see from all those values we just computed here, in this interval from the negative half pi to half pi, tangent x is increasing. You see, from the negative 92.6 to the negative 14.1 and to the negative 1.73 and then to 0 and then to positive 1.73, right? So in negative half pi and half pi, this open interval, tangent x is increasing.